1.6 from section 1.1. I want to do this example because I think it's a poorly written example, which can make it kind of confusing. The way it's written, it says evaluate this function at these 4 points. That doesn't make any sense. You're not evaluating the function at this 4th point right here. You can evaluate it at the top 3 points. But then what you want to do is evaluate this entire expression, not this function at this point. Okay, maybe it's nitpicky, but it at least bothered me, so maybe it bothered somebody else. So let's go through and do this. So for part A, it says evaluate f of x at 2. In other words, determine f of 2. So just reading this, being able to translate into this is a good first step. And then if you get there, the way you can finish the problem is you can say, well, this essentially is kind of the blueprint for this machine f. It's saying when you put x in, this is what comes out. And so this question is asking you, all right, that's great, you put x in, this comes out, but what will come out if you put 2 in? That's what I'm putting right here. If you put 2 into this machine, what will come out? Well, it would be very similar to this, except where you see an x, there'd instead be a 2. So it would be 2 squared plus 3 times 2 minus 4. And 2 squared plus 3 times 2 minus 4, well, that's what? 4 plus 6 minus 4, which is 6. So if you're told to evaluate f of 2, your answer would be 6, and the logic would be right here. And B might look harder, but it's actually easier. For B, you're asked to evaluate f of A, not this A, this A. It's just saying you got this same machine, but now instead of putting a 2 in there or an x in there, you're putting an A in there. Well, how can you put an A in there? I don't understand. I don't know what A is. It's nothing. It's just A. Don't worry about it. It's just everywhere you see an X here, change it into an A. So do the exact same thing you did here, except instead of substituting in 2, substitute in A's. You get A squared plus 3A minus 4. Right, I got that part, but where do I go from there? You don't go anywhere from there. That is your answer. This is f of A right here. Tricky maybe because it seems like there should be more to do. What, do I solve for something? Do I factor? No, just this. See? It's kind of similar. What it's saying here is that your input is this expression now. So I could put numbers into functions. I could put constants, letters into functions. I can also put expressions, something like a plus h, into a function. That might seem strange, but really I can just follow the same blueprint. Everywhere you see an x, instead write a plus h. So now it's a plus h that's being squared. And from that I want to add whatever 3 times a plus h is equal to. And from that I want to subtract 4. And where do you go from there? Well, it's kind of up to you. You could leave your answer just like this. There's other ways you could write this answer. Maybe for now I'll leave it like this, but I'll leave myself a little bit of room because it's going to turn out that I'm going to want to simplify that answer for later. D. It cannot ask you to evaluate this thing at this point because this is not a point, but it could ask you to evaluate this expression right here. It could say, hey, you just figured out what is f of a plus h. You did it right here. That's part C. And you also figured out what is f of a. That's just right here. So you could take your answer to part C and subtract your answer to part B and then divide that whole thing by the letter H and you get your answer to part D here, I guess. Why would you do all that? Well, for now, you just do it to prove that you can kind of push symbols around on a page, just simplify things. It turns out that this thing is very important. It's called the difference quotient. You'll get into it when you take a calculus class. But for now, you're evaluating this thing by just saying, okay, well, f of a plus h, I figured out in part C was equal to this whole mess. Actually, before I plug that in here, I'm going to simplify. Maybe I'll simplify in blue to really emphasize that the reason I'm doing this is for part D here. A plus h squared, that means a plus h times a plus h. So if you use kind of the FOIL acronym, hopefully you know what I'm talking about here. You can say a plus h squared is a squared plus 2ah plus h squared. It's not a squared plus h squared. You can't take this exponent and distribute it over a sum like that. Instead, think about it as a plus h times a plus h and FOIL. I can get rid of these parentheses by taking the 3 and distributing it through to get 3a and 3h minus 4. And you might argue that this doesn't look any simpler, and I don't know that it is any simpler. I kind of prefer the green form. But I'm going to use this second form here when I evaluate, and the reason why is it will allow me to simplify things nicely. So I got a squared plus 2ah plus h squared plus 3a plus 3h minus 4. And that is just f of a plus h. From that, I want to subtract f of a. And I want to subtract the entire f of a. I don't want to just subtract the a squared. I want to subtract the a squared plus 3a minus 4. So it's important that I put this all in parentheses to make sure I don't just subtract the first term, but rather subtract the entire thing. And then don't forget that entire thing's divided by h. Wait, what is h? I don't have an h up here. Yeah, h is just h. You're just leaving it as h. It's not f of h. We're not taking h and putting it into the function. It's just the letter h that goes right here. And I guess this is a perfectly fine answer. This is equivalent to the answer, but you can clean this thing up a lot. I can say a squared minus a squared. That just cancels out. And then I got a 3a here minus a 3a here. Maybe now you see the importance of these parentheses, because otherwise you might think 3a and 3 more a is 6a, but it's not, because there's 3a minus 3a. So those would cancel. And negative 4 minus another negative 4 is the same as negative 4 plus 4, and that cancels also. So when all that dust settles, when all that stuff cancels out, I'm left with 2ah plus h squared plus 3h. Right, this thing canceled out. I still have this one and this one. This thing canceled out. I still have this one and this one canceled out. And that whole thing's divided by h. And then, hey, how convenient. I have h's in each term up in the numerator, so I could factor out an h from each term in the numerator to cancel that with this h in the denominator. The way I'm writing it might be a little bit of overkill, but it's the one thing that I see students mess up more than anything else. So I'm going to write that extra step, and I'm going to talk for a minute. Everyone wants to take this h and cancel it with this h, for example. Can't do that. You can't cancel over addition and subtraction. You have multiple terms up here. You can't cancel an h from one of the terms with an h in the denominator. You can only cancel an h if you have one in each of the terms. The terms are the things that are separated by the plus and minus signs. So I have 3 terms. This is one of them. That's the second one. That's the third one. You want to cancel an h, but you can't just cancel these h's. You have to cancel an h from each of these 3 terms. So you might be able to jump straight from here over to here, being like, yeah, this h is gone, one of these h's is gone, and this h is gone. But for me, it helps to factor out an h so that I can see that these h's cancel. I cannot cancel these 2 h's because I can't cancel over addition, but I can cancel these 2 h's because now I'm canceling over multiplication. These h's cancel. I get 2a plus h plus 3, which I'm going to say is my answer. Equivalent to this thing back here, but a hell of a lot prettier. So I'll call that the answer, and I will call this example done.